Okie dokie. If you watched 113.2a, here we're doing 113.2b, which is going to use the same process, just with weirder functions, it appears. So I have 4 examples. Let's jump right into it. I would recommend watching 113.2a because I'm kind of going to speed through the inverse process because we did it in that video. So first step, rewrite f of x as y. So y is equal to 1 minus 5 over x cubed. Now swap x and y, so x equals 1 minus 5 over y cubed. Now our goal is to solve for y. So first step, subtract the 1. X minus 1 equals negative 5 over y cubed. Now I'm going to show you a very useful algebra trick, and that is if we're trying to solve for y, but it's in a denominator, we're going to multiply this whole thing up to the left side, or basically multiply both sides by y cubed, but simultaneously divide by x minus 1. So what's going to happen is x minus 1 and y cubed are going to trade places. Okay, so y cubed gets multiplied up to the left side, while x minus 1 gets divided to the right side. And just like that, we have y cubed by itself equals negative 5 over x minus 1. We want to get y by itself. That's the goal all along. So we take the cube root of both sides, leaving us with y equals the cube root of negative 5 over x minus 1. Let's see how close we are to an answer. We see... Okay, scanning through them right now. Okay, I would say hopefully if you can go with like one of the closer answers, I guess what I'm saying is like, let's start with the numerator here. Or I'm trying to decide which route to go. All right, let's start with this. If we have the cube root of this whole fraction, that's equivalent to the cube root of each of them. Okay, so that's a fair place to start, right? Cube root of negative 5 over cube root of x minus 1. So I'll just go ahead and say, if we have cube root of negative 5, if we're taking the cube root of 5, that's not going to give us 125. 125 is 5 cubed, and so we can eliminate that. And then I guess I'll say c just looks ridiculous. So I'm going to eliminate that because we don't even see a 5 on top or a cube root of 5 on top. And then between a and d, we have cube roots, we have cube roots. So I would just say, obviously the 5 is not negative in them. So this negative kind of has some free range here. So like looking up here, they could have easily just like taken that negative from the numerator and put it with the denominator. So I think that's what they've done here. So let me kind of rewrite some stuff. Maybe making the denominator negative, distributing a negative to the denominator would have given us cube root of negative x plus 1. Do we see something like that? We kind of do. Let me do one more thing. Negative x plus 1 is the same as 1 minus x. They've just swapped their places, and we get option A. All right, kind of a fun one to play around with. Let's do 3 more examples and talk about why that answer that just popped up is our answer. All right, inverse function. We're calling this y equals negative 6 cube root x minus 8. Swap x and y. So we get x equals negative 6 cube root of y minus 8. And now solve for y. Add 8. Divide by negative 6. So we'll have x plus 8 over negative 6 equals cube root of y. Now, before we do the last step, what I might say is we've seen this before in the last types of problems. So I might say since none of the answers are probably divided by negative 6, let's pull that negative out in front. And then what I might just leave it out in front actually. All right, I'm gonna leave it right there. Now, last step. To get rid of a cube root, we are going to cube both sides, or raise both sides to the power of 3. So we'll be left with y equals really just all this stuff cubed, right? Okay. Okay, yeah, I think we're safe. All right, so we have a negative. We have x plus 8 being cubed. And what I'm going to do is just distribute. I'm going to distribute the cube to the numerator and denominator. So like this. So we have x plus 8 on top cubed and 6 cubed on the bottom with the negative sort of out in front. And this y equals, I don't think I mentioned it in the last problem we just did, but this y that we just solved for is now our inverse function, okay? Okay, so x plus 8 cubed. We want to see x plus 8 cubed in a numerator, not in a denominator, so we can eliminate that. This is x minus 8 cubed. Now, we don't want to see the cube root, no, so that leaves us with x plus 8 cubed in option D, and then you could probably justify where they got the 216. That's likely from 6 cubed, so 6 cubed is 216 with a negative out in front. Just dividing by 216 is the same thing as multiplying by 1 over 216. And they have the negative out in front. Hope that makes sense. Lots of pieces putting it together. You get it. All right, let's keep going. Which of the following is the inverse of this? Y equals 1 over square root of x minus 3. Now swap x and y. Bada bing, bada boom. Now solve for y. So we're going to add the 3 equals negative 1 over square root of y. Let's do our trick. If our variable that we're solving for is in a denominator, let's get it out of the denominator. So bring it over here, but while we're doing so, divide by the x plus 3. So swap the places of square root of y and x plus 3. Nice algebra trick. I'm telling you, it comes in handy. Now, last step, to get y by itself, we're going to square both sides. Squaring the square root of y gets rid of the square root, so we are just left with y equals negative 1 squared. Well, negative 1 squared is just 1, right? So negative 1 squared is just 1. And then on the bottom, we have x plus 3 squared. I'm assuming this might be our final answer. Let's see. Looks like option A matches this spot on. So we're done just like that. Let's do one more example. All right, this might be similar to one we've seen. Let's see. So y equals negative 7 over cube root of x minus 9. All right, swap x and y. Now let's solve for y. We're going to add 9. And our variable that we're solving for, the y, is in the denominator. So let's multiply it up to the left side while dividing by x plus 9. So swapping the places of these two terms, or these two expressions. And then this looks pretty good. Let's go ahead and cube both sides. So to eliminate a cube root, we are raising both sides to the 3rd power. So I'm assuming what they've done is taken negative 7, cubed it, x plus 9, cubed it, and then went ahead and called negative 7 cubed negative 343. So 7 times 7 times 7 is 343. And if you cube a negative, it remains negative. And then we still have x plus 9 cubed in the denominator. So I think that's option A again. And we're done. So we can kind of pick up on a lot of like similar processes as we do more of these same ones. So pick up on those little patterns and, run with them. It seems like they're going to be kind of similar solution steps every time. So hopefully it just takes a little bit of practice and playing around with them to identify your answer. If you have questions, though, let me know.